Mark or
Yes.
yes.
Section 7.2. Page 44, question number 82. About finding the reciprocal.
Oh yeah. So real quick example without as much stuff as I got. If I said find, and real quick, if I said find the reciprocal 2x over 7. And so what would that become? 7 over 2x. Good. So you got to put that x on the bottom. Right? So this one says 7.25x. So how is that fundamentally different from this? So what should you do first? It's not really common in there, but this is written as a decimal.
Right.
And it should be written as a fraction, so then you're able to flip it. So what is 7.25? That's 7 and 1/4. Which is 4 times 7 plus 1. 29, 4. And if I put the x on the outside, that freaks people out. They give me the wrong answer. That x is actually understood to be up. So when you reciprocate it, what should it become? 4 over 29x. Right? If the x starts off up top, it's got to flip down to the bottom when you reciprocate it. Cool?
So whenever you have it, whenever it's in decimal form, you have to convert it to fraction.
Yeah, because you could make it 1 over 7.25x, but that's not really... Reciprocation wants to take a fraction and flip it. So if it's a decimal, that's almost by definition not a fraction. You have to put it in fraction notation first. It's just convention to do that, because then you can flip the fraction. Yeah. Is that cool? Or is that understood?
Yes.
I won't make you go that far. I'm not going to say it's cool. Yeah.
Which number and which section?
Oh, that was
7.2.
82 and 7.2, yeah. Jeez, you guys are so needy. I don't know which one we did. That was a joke. It's okay. They're like shit. Alright, so anything else from homework? You guys doing the homework? Alright, it's good. It's good.
I have a question.
Yeah.
When I was doing I don't have the book, I was doing it online earlier over at the center thing, and some of the things to reduce, like they can see right away it can't be reduced. Is there a trick to that?
Like
I mean,
numbers?
Factor.
Oh.
You're gonna factor something. And
Well, I mean, like there's one problem that is like that in the homework. So here's a giveaway. To be able to reduce this, you'd have to be able to factor the top. Can you factor the top?
well, you can't. I don't
No, it's
understand
a
why.
sum.
Because it's
It's
a
just
Sum of squares. Sum of squares. Yeah. The only reason I'm allowed that I can factor this is because that sign allows me to have two different signs when I break it up. Right? If I multiply to be negative, I have to have a positive and a negative. That's the only way. I can't be both negative.
And when you do that formula they give you, it's A plus B, A minus B.
Exactly. So then the middle term cancels. This would require them both to be the same sign. The middle term wouldn't cancel. It could never become this. So that's why you can't factor sum of squares. It could also be something like if I had that, why should that be very quick? Can you guys, what's the only thing that could possibly factor?
N plus 3 and 3.
What's happening?
X plus 2x.
Can this factor? Are there factors of 1 that add to be 3? I mean, that should be quick, right?
Yeah.
There's no numbers that multiply to be 1 and add to be 3, because the only ones that multiply to be 1 are 1 and 1. Can't make 3 out of that. So that's why some of that might be really quick for them. They know exactly what to look for. You see what I'm saying? Mm-hmm. Yeah. So it should come to you as you look at it. Now, unfortunately, some people will. Let me see. I don't want to put this. Yeah. If I had this. People think that it's this, and it's because their brain is reaching it, saying, well, 1 and 1 add to be 2, and they multiply to be 1, but what's wrong with that reasoning? You're supposed to they're supposed to do what to make 2? Multiply to be 2 and add to be 1. And there ain't nothing that multiplies to 2 and adds to be 1, is there? But the brain is saying, no, it's got to work, it's got to, and then I can cancel that, yay.
Yeah.
But no, this won't. The 2's in the wrong place, right? So be real careful about trying to force it. At the same time, don't think every other one is not factorable. Right? The minute you learn there's primes, I always get people that say every other one is prime. It's prime. It's prime. I don't know. No, it's not going to happen that much in the homework.
Once in a while. Once in a while.
Once in a while, yeah. Maybe 2 out of 80 problems. Yeah. Okay. Is there anything else from homework? I've noticed there are more people signed up for my math lab than are actually doing homework in my math lab. So hopefully you're actually doing homework out of the textbook. That would be good. Yeah.
Can you 69 on 7-1?
Let me see. All right. So this is page 440. Oh yeah. All right. Did we? I can't remember if we looked at that. So this one is this, anything that comes after synthesis, you know it's going to be a little bit freakier. So let's see, which one was that? I've already forgotten. 69, right? So what do you think you can do on the top and the bottom? Okay. Grouping. And it comes out a little different than you used to. So what comes out of these 2?
X to X cubed.
Good? So what's left?
X squared minus 2.
Good. What comes out of here?
4.
4.
X squared minus 2.
So that's good news, right? So the top, we're on the right track. On the bottom, what comes out of here?
X squared 4. X squared 3 minus 2 plus 2.
That's
4. X cubed minus 2 plus 2.
Plus 2.
Good. You can take a negative out so both sides should change.
Yeah.
All right, so up here you get x cubed plus 4.
X squared minus 2. X squared minus 4. X cubed plus 2.
Right there, 2 things. Does anything cancel? I'm going to say a word right now. It's going to give away what it is. Does anything cancel yet?
Not yet.
Not yet. Because they're not done factoring yet. There's one piece of this that's really, really evil. Yeah, which one can I still factor?
X4.
Yeah, that one still has, they're both squares, and there's a difference. Right? So this piece, just that one piece, how does that factor?
X squared plus 2.
Now what cancels?
X squared minus 2.
So then you look at that over that times that. You see that, Trent?
Yeah.
That one piece here factors still. So you group the top, you group the bottom. You can take that out here. You can take that out here. And then this is a difference in squares. Yeah. It's just really easy to miss this and then to try to force something else to do something. Yeah. But that's the only thing that'll cancel. That's why it's synthesis. It's like a lot of crap and only one thing cancels. Okay? Anything else from homework? It's a very strange semester, I gotta tell you. You guys doing right? You guys feel like the whole week is just like right on top of us right now. This is the last. And we have a class tomorrow. A few of you guys?
You have?
Huh? No, not this class. They have Friday classes. All right. I don't. All right. So let's do a couple of review things from 7.6, and then we're going to get into the beautiful word problems in 7.7. You're welcome. Let's see. What's that?
We said we love those.
Oh, I see. Okay.
We're just conferring with one another on how fun they are.
It's a good thing. Let's see. Let's see. Where do they got one like that? Here we go. So, all right. Look at this problem here. Okay. So what would I do here?
Common denominator.
Okay, cool. And the thing that you got to be real careful about is you don't just focus on those things that have a bottom. Everything has a bottom, right? What's underneath 1?
1.
1. What's underneath X?
1.
1. What's supposed to be under there so it's the same as everybody else?
X minus 3.
Good. So you know exactly what to give, right? So you don't just, I see students doing stuff to equations and they just leave the thing alone that doesn't have something, but everybody has something. You got to make them all have the same denominator before you can keep going. So he needs X minus 3. All right. He needs X minus 3. And then, of course, you're allowed to kill all the bottoms just because this is an equation. Yeah. So the and can get rid of it. So if I multiply X minus 3, all the bottoms cancel. So what are you left with? X minus 3.
Plus X minus 2 minus X squared 3X minus plus
Negative.
Plus 3. Negative's got to come. Yes, ma'am.
Isn't it x plus 3 negative 3 times negative 1 is it positive? Or is it where you're, yeah.
It's just a positive 1.
Oh, I'm looking at, I totally did not know that.
That's all right. So how do I solve this equation? What's special about this equation that tells me what to do?
So you have minus x squared.
What's special about that?
Now you're going to have, you have to equal it to 0.
Good, right? I have a power that's different from my other powers of x. I can't get all my x's together, so I have to get it equal to 0 and
From there
factor.
factor.
Good. All right, that's what. So I try to teach you what to look for in your equation that actually tells you how to solve it. Right? Not all the time does math actually say, hey, this is how you solve me. But this is actually doing it. Saying, hey, get all my stuff on one side, get me equal to 0. Cool.
Excuse me, what would tell you that again? I'm sorry.
The fact that I have a different power on one x than I do on the other ones. And a higher power, so it's squared. If that wasn't there, all I would do is get all my x's on one side, get my numbers on the other side, just like old times, right? That's there, shit, I can't get my x's together. You with me? Oh, old times.
The good old days.
So then from there, are you saying 2 minus x squared plus 3x equals 0?
No, definitely not. You can't just make a new equation. I have to work with this equation, but I just add,
Move it
subtract, get everything on one side. Yeah.
Can you do it on the board?
Slowly.
Instead of
Slowly. Yes.
where?
Like, can you continue?
Yes. I'm just talking about it, and now we'll do it. So now I'll add x squared. Subtract 2. Add, subtract 3x. So over here I get 0. Here I get x squared. I got a minus 5 minus 6. Is that cool? And then what's x plus x minus 3x?
X
Minus x. Good. Just getting all my like terms together over there, right? You could have gotten the like terms together first, maybe that would have been less disorganized, but however you get it all together is what you want to do. And then, of course, I want to factor. I always have somebody that adds these over and takes a big old square root of all this crap, and how I know this is not possibly the answer? My x is there, and my x is there. That's not solved for x, right? So it's no good. No good. So how do you factor this thing?
X minus 3.
So you get x equals,
3 or negative.
can you guys see that? Does everybody see where those numbers came from?
Because you moved.
Okay. All right. Yes, sir.
Is that a different way of doing it, like, beside, if I was to just do like 1 times 6 and then find the difference, is that a longer way of doing it? Or is
That is a longer way to do it. I showed you guys this way first, and then we talked about what to do if there's a number that's not 1. If there's a number 1 here, the numbers you get that make these work is all you need. You're done. Put them in there. If you do the grouping, if you break this up and do the grouping, you'll get here eventually. But why? You only have to worry about that if there's a number right here that's not 1. If there's a number right here that's 1, then the numbers you find just go right in. There's nothing freaky about it. It's nothing to be careful about. If this is just a 1, what numbers don't make negative 6 and make negative 1? Negative 3 and 2. Put them in. You're done. It's only if there would have been a 2 out there, now I would have had to break the middle term up and group it. That's what you're saying, right?
Yeah. Yeah.
But if there's a 1 out front, I'm done.
So you just knew, because it's such a simple thing, that negative 3 times plus 2 is...
Well, that's what you'd have to do anyway, right? You have to figure that out anyway. And then, now real quick, on the side here, so if I have this and I figure out that negative 6, I get negative 3 and 2, you could do this. Right? You could do this. And if you like it, okay, I don't understand. I want to show you why I don't understand. I really want you to understand why this is just like crazy extra work that you don't have to do. But just to show you, it does come out the same thing. What do you take out of here? X. 2. So of course you get x minus 3. X plus 2, the same thing, right?
Yeah.
So once you figure these numbers out that you would have to figure out just to rewrite this, don't rewrite it. Just that's the answers.
Okay.
That's what's so much easier when there's just a 1 out there. Everything is a lot more known. If there's a 4 out there, I don't know if it's 2 and 2 or 4 and 1 or 1 and 4. You know, so that's what the grouping does. It
Or
has,
just one out there, though.
huh?
You gonna have one that you test, just the one out there?
Could be. There could be something with an 8 out there. I don't know.
Probably.
Yeah.
Doesn't it have to be in parentheses x minus 2 and then x plus 3?
Why?
Because up at the top it's x squared minus x minus 6. So the 2 have to times to make negative 6, and then they have to add the
Negative 1. So the bigger one has to be negative.
But
Negative 3 plus 2 is negative 1. 3 plus negative 2 is positive 1. Yeah.
Okay.
So the middle term, actually, when they're different signs, the middle term tells you what the bigger one is. So then it actually comes out to be that way. Now, I'm not done with this problem, in case you're curious. Or if you thought we were done, we're not done with this problem. Because if you stop there, you're going to lose points. Right? Just because I'm a jackass. No, I'm not a jackass. Why would I take points off? What's wrong with this?
You have to plug the values back into the X.
Yeah, you didn't check. You gave me an answer that's bogus, right? Which one of these answers does not work?
X plus 3.
Yeah, why does positive 3 not work? What does it do to the original equation?
Because
It makes a couple of these things undefined, right? So I gotta throw it out. It's not allowed to be there. So I only got the one answer. So that's what we talked about the other day. It's called extraneous solutions, right? Sounds like something mad scientists would have. But that's an extra extraneous, an extra solution that came out because we multiplied by x minus 3, didn't we? So the math said, oh, you didn't realize that that would make that 0. You weren't really allowed to do that. So we have to throw it out. You guys with me? So you have to check at the end of a problem that has variables on the bottom that none of your answers makes anything undefined. If they do, you got to throw it out.
So how do you check it? You go and plug it all back?
No. You just look. What would make this undefined?
Positive 3.
So we got to throw that out. It can't be an answer. We got to throw it out.
Oh, if it was a negative 3, it would work.
it would have been fine. Yeah. And -2, of course, is cool. It doesn't make anybody freak out.
So would that be no solution?
If that was the only possible solution, yes. But there is this. So our answer is only -2. It's not two things, it's only one thing. Cool. I like it. Okay. All right, anything else from homework? Was that something we did? Oh, yeah. That was just me doing stuff, right? Okay. Let's try one more, and we'll just let you guys do this. Here, try this one. Hello.
Is this section 7.6?
Oh, let's see. Do I want to be able to? Yes. Okay. So I modified their question just a little tiny bit. So there's two ways you can do this, but there is something you got to be careful about. Didn't we come in after we did these green sheets? Oh, just one question. Well, it should be negative one. Yeah. And then you can see what you have to be careful about, because that's not, it wants to be the same, but it's not quite.
Oh,
So I don't mind you turning that around, it's fine, but how could, because this is negative powers make things, a negative number won't suddenly make it.
okay.
Yes, good, exactly. So that negative you can actually, yeah. Yeah. So what's the thing you got to be careful about on this problem?
-1.
Yeah, so this is T minus 3. This factors to be 3.
Minus T, 3 plus.
Okay, good. So they almost share this, but it's not the same.
That's negative T and a positive T.
Yeah, it's no good.
Right.
So how do I make this become that?
We can change the sign?
You can't just change the sign, but you can take a negative out. Right? So if I take a -1 out, this becomes T minus 3. And this is 3 plus T, but just to make it look more normal, I can make it T plus 3. Yeah.
So if we get a question like that in the test, and we not show you like you take kind of like with the -1, so like you take.
Well, you have to show me because it's going to change the problem. There's now a negative part of that
So
term.
like we can't just like write it as a T minus 3, T plus 3.
Totally not. Because T minus 3, T plus 3 does not equal 9 minus T squared. It equals T squared minus 9, which is an entirely different number. Yes. Yeah.
multiply the 9 minus 2 squared by negative 1.
Right?
Yes, good. So from the very beginning, we could have multiplied top and bottom of this by -1 and turned this bad boy around.
Then it goes into 2 squared.
Right.
Yeah.
So let's look at it. That would be a lot less stuff here. But now I want to show you. So if you did that, so I turn this, if I take a -1 out, or if I just multiply top and bottom by -1, right? Let's look at it more like that. So if I have this and I multiply top and bottom by -1, so it'll be 5 over t minus 3 plus negative, so a better way to write that is minus 30 over,
Minus 9 plus.
yeah, so t squared minus 9. But do you guys see how that's exactly what would happen here? What's 30 divided by -1? Minus 30. That would be the same place, right? So that's that thing we looked at before in a couple sections ago where you've got to be careful if they're not quite the same, but they're offset by a -1. You have to take the -1 out.
Will you still factor that one?
Yeah, definitely.
Okay,
Yeah.
so then you still come down to t plus 3 and t minus 3 for that, factoring the t squared minus 9, right?
Totally. Okay, so now it'll be up here. No, John.
So then you have 5 times the, up top 5 times t plus 3 in parentheses? Because wouldn't you move, you're multiplying
Oh, good.
top and bottom, right?
Yeah, so now what is he missing?
T plus
t plus 3.
T plus 3. Anybody else missing something?
Yeah.
Yeah,
The one,
The one is.
yeah, the one.
So that's what always happens. People, and I always get somebody ask me, well, why do you have to worry about him? He's not a fraction. Yeah, he is.
Yeah, it's 1 over 1.
Totally. Yeah, he's 1 over 1.
Hey Jeff, did you just move the negative sign when it was down with the t's?
Yeah, what's
You
here?
just
Carl,
changed the positive?
Carl, what's 4 divided by -8?
No, 4. I mean 2. -2. Negative, yeah.
-1/2. So it's a negative.
Yeah, yeah.
All that matters is it's a negative number, but it's convention for us to put the negative on the top, right? So 1 over -2 is the same damn thing, but it's convention to put the negative on the top so we don't lose it. Put it up top, right? They mean the same number. 1 over -2 is the exact same number as -1 over 2. It's just convention to move the thing up top.
Now, I don't understand you. Oh, okay, over there to the right of what you just did where it says 5 over t -3 -30
Yes.
over t2. And then I'm looking up top right above your head there, and you just put the negative sign instead of positive sign between the 30 and 5 there.
That's right.
So you just, to alleviate that -1, you just change that sign?
So 2 ways to look at it. Either 30 divided by -1 is -30, or 30 times -1 is -30. Either way you look at it, you end up with a -30. Right?
Okay.
Yeah, good. Okay, cool. Okay, and then now, so what does he need? He needs everything. He's got nothing, poor little dude. Okay, and now you can do what?
Cancel.
Kill the bottoms, right? So that if I multiply everything by that, all these bottoms die.
Do you have to show that step, that you're multiplying?
Show me something. If you need to for yourself, you can put it next to each piece so you can really see it cancel. But I'm multiplying that by each piece.
So we have to show you that we cancel, or we can just put like the equation and then
That's right. Show me, at least put a line through something.
Okay.
Yeah.
So does that equal 0?
So that equals 0. What do you mean?
Do they not, they can't cancel, right? Like top and bottom? Like the two minus...
Yeah, this canceled with this
No,
and
the
with
other
this.
side.
With this.
But the top is the same as the bottom. On the other side, it goes sign.
from what?
No, that's gone now. You see?
Oh, so now you can't cancel
It
the
canceled there because I had to multiply both sides by this. Yeah. Or if you forgot to give this anything, you have to multiply both sides by that to kill these bottoms, right? So then it'll be 1 times that. It'll still be that. Either way you do it, that's got to be over there. But the big mistake is people write the next equation and still have equals 1. How did one side change totally and the other side nothing happened? That's not good. Right.
But just, there's something I didn't get. The -1, what do you get with it? -1.
Oh, here.
Yeah.
What was here before?
Oh, plus.
Plus sign. So now 30 divided by -1 is minus 30. Do you see that?
Oh, okay.
Yeah. Okay. Yes?
So then, okay, so then I get on the next step.
Okay,
you're-
okay. So next step, what do you get?
5t minus plus 15 minus 30 equals 1t plus 3. I mean, minus 2, yeah. I don't know the t squared last time.
Yeah, you got to multiply it out so you can get all your
Okay,
terms
that's
free
what I
to
was
move
gonna
around.
say. It goes
Good.
back to where it
Good.
was, becoming that.
Okay, cool. And now we're at like the last problem we just did, right? What tells me what to do here? Yeah, move anything on one side because that t squared there, right? So if I put my like terms together here, I get 5t minus 15. Now if I subtract 5t, add 15, subtract 5t, add 15. So this side I get 0. Over here I get t squared minus 5t plus 6.
You should get, hang on, we should get that plus, oh, you move the 15 over. You still move the 5.
Yeah, exactly. I like it. I always stop to let everybody catch up, and then there's always people going, but isn't there more? Yes, there will be. Let's let people catch up. Alright, and like Aveen said, you've got to now factor it. Right? That's why I made it equal to 0 so we could factor it. Can we factor that?
No.
Yeah.
Well, it's a plus.
1 times 6, 5.
You gotta be careful. If I do 1 and 6, they have to be different signs to make 5, right? 1 plus 6 is 7. But if they're different signs, they can't make 6. So yeah, it's gotta be 3 and 2. There you go, cool. So t minus 3, t minus 2. This is very simple, really tiny numbers, but it's actually one of the most evil ones out there because 6 and 1 makes 5 and 2 and 3 makes 5. It just all depends on the signs. The signs have to be the same, so I can't use 1 and 6, that's 7. Shit. I gotta use 2 and 3. So then here I get t equals 3 and 2. And of course, do they both work? Are they both okay? Which one's not good? 3's not good because it would make this guy freak out. Yes, ma'am.
So confusing, like how do you know if it's work or not? Like how do you
So from the very beginning, if I write an equation down, let me just write a different equation, then we'll talk about that one again. If I just write an equation out of nowhere, I already know what cannot possibly be the answers. What can't possibly be the answers? Anything that makes anything undefined. So x couldn't be 1, 10, or negative 5. So here, at the very beginning, before I do any work, I can even take a second and just off to the side say t can't be 3 or negative 3. So if I get one of those 2 answers at the end, I know I can't include it. Freaks my dude out. Okay. All right. Okay. So we're going to get into 7, 7. All right. And one kind of problem that's in here is called a work problem. Not a work problem, it's work problem. Oh, you all look like you're about to be tortured or something, or you are currently. I understand math is like that. So, the idea here is really kind of nice. If I can mow a lawn in, like my neighbor's lawn, I can mow their lawn in 2 hours, because they got a big ass lawn. They have the weed eat and everything. But my little brother, he can mow it. My little brother, he's lazy. He can mow it in 3 hours. So then I say, okay, if we work together, it wouldn't make any damn sense to say it would take us 5 hours. Right? So assuming our working together won't slow us down, with me, that we just each do our work, it should take less than how much to do it? It should take less than 2, right? If it takes me 2 hours to do it alone, if I got somebody helping me, it should take us less than 2 hours. So we're going to find out exactly how long it takes us to do it. So the way this works, it's kind of nice if you let it. So I can mow one lawn in 2 hours. If I work with my little brother, he can mow one lawn in 3 hours. So together we can mow one lawn in I don't know how many hours. And this really has to do with the percentage of the work we've done and all kind of stuff. But I love the way this kind of sets itself up. So I can do one job in 2 hours, they can do one job in 3 hours. So together, we can do one job in how many hours? And now you see why, you know what's expecting these word problems. All the equations you set up are going to be equations that you saw in the previous section. That's the whole idea here, right? So how do I solve this equation? Cool. So what's the first dude need?
3 and 3.
He needs a 3.
3 and 2.
No, he's got a 2. He needs a 3
X.
and an X. He needs 2 and an X. And he needs 6. 3 times 2. I like it. So now they all have 6x. So let me be very explicit about this next step. So now I can do this. Right? Since I have an equation, I can multiply both sides. If I multiply this side, I'm going to distribute. So let me just go ahead and write it next to everybody right off the bat. And then what happens here? 6x cancel with 6x. 6x cancel with 6x. 6x cancel with 6x. And then what's your equation now?
3x.
Okay. That's nice.
5x.
5x. So x is 6/5 of an hour, right? So that's an hour and 1/5 of an hour. And what's 1/5 of an hour? How many minutes in an hour?
12.1.
I like that, but no.
More than 10.
You're close. More than 10. 5 goes into 60 12 times, so it would be 1 hour and 12 minutes.
What did I say?
You said 12 and a half. You were really close.
All right.
Yeah. Okay. So they're going to give you problems where they're typing up a paper or they're doing some kind of a job, and the other person can do it in less time or more, and then they work together. Okay. So that's the kind of problems you get there. Okay.
You know in real life that would never work like that.
Yeah, of course. So one thing about math, I want to tell you some stories. So I once had a carpenter in my class, and there's a problem you could do for a word problem where you take a board and you cut it into 3 pieces, and you say the smallest piece is 2 less than the middle piece, and the middle piece is 3 times as long. You with me?
Yeah.
So we did the whole problem out, and then he raises his hand and he says, "You know, Mr. Waller, when you cut wood, this is how when you cut wood, you lose a quarter about an eighth of an inch is in the teeth of the saw." I'm like, I said, "We use lasers." But I mean, it's a really good point you almost bring up. I know you're mostly joking, but the math we're learning right now is just getting used to the ideas that are used in mathematics. When we get closer to wanting to really model something in real life, we're going to have to learn how to adjust our equations a little bit. You with me? So math itself is always idealized. It starts off with no friction on the table, and then you can see how some fastening is going and so forth. Or no air resistance, right? So if I drop something, I neglect air resistance or something. You guys kind of with me? So all my equations I get for those situations are not going to work in the real world, but they're a starting place. And then you learn how to adjust the equation a little bit to account for air resistance, or to account for friction, or to account for losing some of the wood in the blade, right? Okay, maybe? Alright. But I mean, it's a good point. That's a really good point. But everything we're doing is idealized. In real life, the reason I said what I said earlier about assuming that nothing is going to happen, if I'm working with my little brother, more than likely, something's going to happen. Have an argument, or we're going to be bullshitting too much, or something. And then all of a sudden it's going to take us longer. You know? So I really want you, so that by itself doesn't discount math. What you're learning is just a starting point. And then you got to get much further in mathematics and start talking about, well, what would the next step be? How do I adjust the equations I've used to account for stuff that we haven't accounted for yet? Okay. So another kind of thing that's in here is one of our favorites, distance, rate, and time. I think you guys were already crazy bummed out. You were bumming me out. And now I can only make you worse off. But that's too damn bad. Let's see. You came to take my jokes, right? Is he serious? Let's guess. Blah, 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 blah. Okay, here we go. Here's example 3. Let's look at this guy. On her road bike, Olivia bikes 15 kilometers an hour faster than Jason on his mountain bike. So Olivia, can you spell Olivia, Jeff? 15 kilometers per hour faster than Jason. Which is good, because you want to get away from Jason. See Jason on a mountain bike. I don't think they mean that, Jason. And the time it takes Olivia to travel 80 kilometers, Jason travels 50. So she travels 80 kilometers. At the same time, he travels, what did I just say, 50? Mm-hmm. Which kind of makes sense, because she's going faster, she should make it further. Right? So this is the same time. So I'm mostly just writing all this up here for people that have a book, but it's a good idea to summarize very quickly what the problem is telling you. Now, you will hopefully excuse me for this, but I teach another class that does this kind of problem. We haven't done this kind of problem yet, or have we? Okay. So, you guys remember this? I put it up here. I should have asked you if you knew it. But it's really easy to remember. It's dirt, right? D equals RT, dirt. Okay? And we do this all the time. If you're going 40 miles an hour and you wait and you go for 2 hours, how long are you going to go? How far will you go? 40 miles an hour in 2 hours. You will have gone how far?
80 miles. 80
miles an hour, right? 80 miles, right? So that's rate times time to get your distance. Okay, we know that. So one device I have to help me set these kind of problems up. So I can use a little chart, and up here I'm going to put distance equals rate times time. Because I got two situations. I got Olivia, right? Cece's situation. And I got Jason. And you start filling in what you know. So it's a nice organizational tool. So what do I know for sure about Olivia? Question.
80K?
Yeah, she went 80 kilometers. And Jason went how far? 50. Now, do I know either of their speeds? No. But I do know Jason, I do know that Olivia is going 15 kilometers an hour faster than Jason. So who's just X?
Jason.
Jason. Because Olivia then would be 15 more than that. So what's her rate?
15 plus X.
Either way, cool. Now here's the key. The minute you get to 2 boxes free, you're going to use the equation to fill them in. Because what's the connection here? Where am I going to get my equation from? How long did it take them to do that? It took them the same amount of time. So whatever ends up here, I'm going to set it equal to that. Because the times are the same. If they would have said, their times added to be 7, I would have said that plus that equals 7. So what the hell goes here? If I know distance and rate, how do I get time? So if I know distance and I know rate, solve for time. How do you solve for time?
Divide by.
Divide by r. Kick ass. What is happening around this room? It's freaking out. Right, winter's coming. The white, whatever the hell. No Game of Thrones? So, Olivia's time is going to be her distance divided by her rate. So what expression am I going to put here? Beautiful. Her distance divided by her rate. Jason, same idea.
Divided by.
His distance divided by his rate. And those two expressions have to be equal. And what is nice about one fraction equals one fraction? There's something you can do here that you can only do in this situation.
LCD.
Well, we can do that everywhere. And real quick, let me show you why this works. I haven't heard the expression yet. That's not okay. So let me show you why this shortcut works. I'm going to do like whoever it was that just said LCD. That's nothing. There's a beautiful idea. That's the exact right thing to do. But there's a shortcut when you have one fraction equals one fraction. So what does he need? X. And he needs. Good. No, he doesn't need a plus 15, right? He needs the whole x plus 15. 15. So then I can fill these, right? I can multiply both sides. So, but look what effectively happens. Where did that x come from? It came from there. Boop. And where did the x plus 15 go? Boop. Right? So this is 80x equals 15 times x plus 15. That came from down here, and that came from down there. This is cross multiplication. The minute students learn that, you guys try to do it everywhere. It only works there when you have fraction equals fraction. Yes. If you try to do it too often, you can do it actually if you're really clever and do it differently a little bit. But I would not suggest to try to do it. This is the only place it really works directly. So then we get 80x equals. Now what do?
Yeah, set it to 0, volume factor.
Don't be saying probably, Carl. Probably crap. Do you have to set it equal to 0?
Huh?
What tells you when you have to set something equal to 0? When you have like an x squared, when you have an x with a higher power. Do I have an x with a higher power? Right?
No.
Not it's God, but yeah. So then 50.
50x plus 40.
So I can just get my x's together, right? There are no x terms that are not.
You got to set it to 0 if there's an exponent.
Yeah, if I put an x squared there, I'd have to get it equal to 0 because now I can't get my x's together, right?
Look at x cubed.
Don't put an x squared. If it was the same thing,
Okay.
yeah. So anytime I can't get my x's together, I have to have a different way to solve it.
Oh, so since they're all like terms, you can combine
I can get them all together and divide by the coefficient. I'm done.
Oh, okay.
Yeah. So I get them all together.
Minus 50x.
Minus 50x, so I get 30x. 750 divided by 30. X is 25. So what does that mean?
You plug it back into
So that means Jason was going
25.
25 kilometers an hour, and Olivia was going
40.
15 faster, so 40 kilometers an hour. So in a sense, the word problems are not going to be very different from before. The equations they lead to will involve variable expressions on the bottom. So then you have to get LCDs, do whatever you need to do. Here you can cross multiply if they end up looking like that. Okay.
What section is this?
7-7. It's funny. When I look at it, I feel like I'm in Dragon's Den or something. Like I'm trying to present. And this cures cancer. It does. Believe me. Who wants to give me $18 billion for that? You're all like, you're not selling me on this shit. What do you call this again? Math? God, it's scary up here. All right. So let me see if there's any other kinds The book itself uses that chart method, so that's kind of nice.
So like if we get an word problem like test with something like that, are you gonna give us like any of these in the test?
What do you think?
Of course.
Well, like if they're like this, like actually like that, well they're easy. Like if you get like
One way to make this more difficult is if I would have said these two added up to be something, right? Because then you couldn't solve this the same way we did. But you'd still just give everybody what they're missing. It's still not that much harder, is it? Good. They're not going to get much harder than this.
Because this is really easy.
I like that expression. I don't hear that very often. Often enough, anyway. Oh yeah, that's right. One other idea that's in this section is the idea of similar triangles. I think it's all I got here is distance, rate, time, and this. And the work problems. So this idea is pretty simple too, and hopefully most of you have taken geometry at some point in your life. If I have a triangle that's got those side lengths, don't freak out. We're not suddenly going to do side angle, side proofs or something. If you remember any of your geometry. It's very simple. If I have now a triangle that is 6 and 8, what does that side got to be? 10. I must have doubled this guy, right? It's not to scale. Maybe he's leaning back. I don't know. That would be 10. So how did you figure out that was 10? Because you can see that the multiple was 2, right? 6 over 3 is 2. So then this over 5 must equal 2, and you can solve it. Now these are nice numbers. You can just figure it out in your head. Your brain didn't even realize that you were sort of using ratios and proportions, but you were. So let's look at an uglier problem and see what we do with it. Blah, 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 blah. Blah, blah, blah. Oh, let's see if they give us any ugly problems. I'm going to make an ugly problem. So when they say similar triangles, it means it's the same triangle. It's just been zoomed. It's been doubled or tripled or something like that. Some multiple, bigger or smaller, right? That's the only reason I can say all the side lengths have to be related that way. So if I have two similar triangles, that one, let's say that's 11, and that's what you got, Jeff? 8. And then this is 15. See, now everything suddenly went wonky, right? But you could do exactly what I said earlier that you didn't even realize you were doing. You got the number 2 by dividing 6 by 3. You just didn't even think about it that way. Your brain just went 2. It's twice as big. But that's how your brain did it. So I want to say this is some multiple bigger than this, right? So whatever this divided, let's call this, I don't know, x. So whatever x divided by 11 is, it must be the same thing that 15 divided by 8 is. The same way that 6 divided by 3 has to be 8 divided by 4. They all have to be 2. They're twice as big, right? So you can set up that proportion. This side to that big side to the little side must be same as big side to its similar little side. So 15 to 8. Now how do you solve that? Cross multiply. Right? You're not going to get a nice, beautiful little number. You're going to get a nifty little decimal or something. But, not all numbers can be whole. So, what's it? Yes?
Don't we have the other side as well?
Yeah, if I wanted to know. I just said I only want to know that side.
Okay.
Now, why could I not figure out that side right now?
Because it's not given.
Because I don't know the original side length, right? And we're not going to do trigonometry suddenly and start
So
figuring out
are we
sides.
assuming that they are the same? Are we assuming that
Yeah,
they share the
I
same?
told you going into the problem, these are similar triangles.
Okay.
Yeah, so they have to be some multiple of each other. So so you get 8x equals 165, so you get x equals
65.
Now what do you get? 20.2. Yeah, what is it? 125. So what is it? 625. Yeah, cool. 625. 20.625, yeah. Does that make sense? This is almost doubled. So this should be almost doubled, right? So it should be almost 22. Okay, there you go. We're a little bit off from 22. Makes sense. If you would have gotten 90 there, you did something wrong. So you should be able to just kind of step back and make sure it makes sense. Okay, good.
So can we call that one 21?
Don't call him 21.
Well, no. No, I mean.
He wants to drink, but he's not quite there yet. Right?
No,
His ID. It's me. Sorry.
For the X on this side, because it's almost double.
Yes. No. It's not doubled, so you can't just say it would be 22 if it was almost double. Yeah. So it came out to 20.65 as a way to check it. It's almost doubled, so that should be almost doubled, and it is. But that's the answer, right? Or I might say rounded to a couple of decimal places or whatever. Yeah. Okay. Maybe. So the three main things in section 7.7, it's the similar triangles kind of idea, the distance, rate, time with the chart, and there's several examples like that in there, and then the work problems. I can do one thing in 7 hours or whatever. Okay. So let's do one more section. I'm joking. Sorry. So chapter. I'm trying to get you guys like a reaction from you guys. So next time I see you next week, we're going to be getting into chapter 12. Radical expressions, radicals, square roots, cube roots. Don't worry, you got to follow your homework sheet. Our curriculum jumps around a little bit in this book. And we'll probably have a quiz next Thursday, but we'll talk about it on Tuesday. Okay, is that all right? Okay. All right. I don't know yet. We'll talk about it Tuesday. Oh, good. Thank you. Oh, good. Thank you. What's that? Yeah, we're probably not going to get all the way through chapter 12. So it won't have as much stuff as it could. Thank you. It'll be for the next test, yeah. Oh, good. Yeah, you can redo it. So you did it?
Yeah.
Oh, I see. And so wait, Laura. You didn't tell me you came in.
When, today?
Yeah. Did you do one of these green sheets?
No.
So real quick, it's just one question on here. It's for the placement. It's I'll let you read it.
Do I have to do it?
It's just one bubble to fill in. Alright, so read that and there's just one question.